Hello, my learned colleagues. In this video, we'll be looking at surface area and volume of cuboid. A cuboid is also known as a rectangular prism. So whether you see it as cuboid or you see it as rectangular prism, they are talking about the same thing. So how can we calculate the surface area and the volume? For a cuboid has 6 faces. So to calculate the surface area, we calculate the area of each of the faces and then add up all of them together. Here, let me use different colors to highlight the faces. Let me start with the face at the back. That's that back there. Okay, let me do it this way to avoid confusion. Remove this face right there at the back. This one. And you also have another face right here in front. Then you have another face. We use a different color. You have another face right here at the bottom. You have it at the top. Then you have this one at the side. You have this at the side. By the time you calculate all of the 6 faces, of course the faces are rectangle. So area of this rectangle here, let me call it A. Area of the rectangle down, let me call it B. The one in front here, let me call it C. The one behind, let me call it D. The one by the side here, let me call it E. And the one here, let me call it F. When we calculate all the areas and add them together, that will give us the surface area of the cuboid or the rectangular prism. So area of A is length times breadth. Area of B is also length times breadth. Area of C is length times breadth. Then area of D is also length times breadth. So adding all of this together will give us the surface area of a cuboid or rectangular prism. Volume, on the other hand, if the volume is straightforward, volume is length times breadth or times width times height. That will give you the volume of a rectangular prism. I think when we take some worked examples, we understand it better. And so let's move into some examples right away. I have example 1 here. It says find the surface area and volume of each of the following rectangular prism. The first one here, let me call it A. Let me call this B. And let me call this C. Starting with area of A, surface area rather. For surface area, we have a surface here which is at the top. We have the same thing right at the bottom. So let's calculate the area of top and bottom. The length of this cuboid is 10 centimeters indicated here. The width is 9 centimeters. So area of top and bottom will be length, which is 10 centimeters, multiplied by the width, which is 9 centimeters. So the two of them will multiply by 2. Since I have the same shape at the top, I have the same shape at the bottom, even though it's not showing it clearly here. So I will have area of top and bottom is equal to 2 times length times breadth, or length times width. There is a 2 of them. So I have 2 times the length is 10 centimeters right there. 10, and the width is 9. Is it 9? Yes, 9 centimeters times 9, which is 10 times 9 is 90, and 2 times 90 is 180. So I have 180 centimeters square for the area of top and bottom. Now we have a side here which is 9 centimeter long and 3 centimeter high. These three here is the same thing here. This side and this side are equal. So then we have this here. We have the same thing right here too. Even though this drawing is not showing it very well. So area of this and this are the same. So area of left and right, let me call it that way. Area, let me use a different color there. Area of left and right side of the cuboid is 2 times length times breadth, or length times width, which is 2 times the length is 9 centimeter, the width is 3 centimeter. This 3 here is the same thing here. So 9 times 3, 9 times 3, and 9 times 3 is 27. So 2 times 27, 2 times 27, that is 54. 54 centimeters square for the area of left side and right side of the cuboid. Then lastly, we have, again, let me use a different color here. We have a side here, which is the front of the cuboid. We have exactly the same thing at the back there. The area of front and back, let's do that here. Area of front and back of the cuboid, again, is 2 times, that is the two of them, that is why I'm multiplying by 2, length times breadth. Since both the front and the back are exactly the same, they are all rectangular faces. So the length here is 10 centimeter, the width is 3 centimeter. So 10 times 3, 2 multiplied by 10 times 3 will give us the area of the two faces. 10 times 3 is 30, so 2 times 30, which is 60 centimeter square. So total surface area, excuse me, total surface area of this cuboid would be on the first side, which is this, 180 centimeters square plus 54 centimeters square plus 60 centimeters square. We use a different color there. Total surface area, let me call it TSA, equal to 180 plus 54 plus 60, all in centimeter square. And let me use a calculator to do that addition. 180 plus 54 and 60, that is 294. So total surface area of this cuboid is 294 centimeter square. That is that for the total surface area. But the question says we should calculate both the total surface area and the volume. For the volume, V is equal to length times breadth times height. The length of this cuboid is 10 centimeter, the breadth is 9 centimeter, and the height is 3 centimeter. So plugging those values into this formula, we have 10 times 9 times 3. I hope that is the values. Yes, 10 times 9 times 3. 10 times 9 is 90. 90 times 3 is 270. With 270 centimeter cube is the area, the volume rather, of this cuboid. Take note of the unit. The unit for area is centimeter square. That of volume is centimeter cube. Y cube, this is in centimeter. This 2 is in centimeter. This 2 is in centimeter. Centimeter times centimeter is centimeter square. Times another centimeter, 9 centimeter cube. So the volume is in cube, while the area is in square. So that brings us to the end of that very question. Now let's look at the second one. Question B. Let me work it here. B. Again, starting with the surface area. We have one surface here, which is the top. We have exactly the same thing at the bottom. So area of top and bottom, area of top and bottom will be 2 multiplied by length times breadth. Since the top and the bottom are rectangular shapes, length times breadth is area of a rectangle. There are 2 of them, the one at the top and the one at the bottom. That is why we multiply by 2. So that will give us 2 times the length of this is 20 meters right here. So 20 multiplied by the breadth is 4 meters right there. 4. 20 times 4 is 80. 80 times 2 is 160 meters squared. That is area of top and bottom. Then area of left and right, use a different color. This side here and exactly the same side here. Is here. That will have area of left and right side. Area of left and right side is 2 multiplied by length times breadth. 2, the length here, the length, let me consider this to be length. Okay, this is bigger, so let me consider this to be the length. And the breadth would be this 4 here. Remember, this side and this side are equal. So this is length, this is breadth. You have the shape here, exactly the same shape hidden here. That I have a 6 multiplied by 4. I have 6 multiplied by 4 is 24. So 24 times 2 is 48. 48 meter square as the area of left and right side. Then lastly, area of the front right here. Let me use a different color. Let me use green, my favorite color. Area of the front, and you also have the same front, the same shape right at the back there. So area of front and back will be area of front and back will be 2 multiplied by length times breadth, which is 2 times the length there is 20 meters. The breadth is this height now, which is 6 meters. So 20 times 6, and that will be 2 times 20 times 6 is 120. 120. 120 times 2 is 240. 240 meters square. Therefore, surface area or total surface area of the cuboid will be this area here plus this plus this. That is 160 plus 48. 160 plus 48 plus 240. 240. All of that in meter square. Let me use a calculator to add it. 160 plus 48 plus 240. That is 448 meter square as the surface area of this cuboid. And the volume, on the other hand, volume of a cuboid is length times breadth times height. The length is 20 meters, the breadth is 4 meters, and the height is 6 meters. So 20 times 4 times 6, 20 times 4 times 6, 20 times 4 is 80, 80 times 6, that should be 480 or so. Let me confirm that. 20 times 4 times 6, yes, 480 meter cube. 480 meter cube is the volume of this cuboid. And the last one, which is question C, let me work it here. For question C, I have starting with the surface area, I have a surface here. I have exactly the same thing at the back. So area of front and back, front and back will be 2 times length times breadth. 2 times the two of them, the area of the two of them, or each of them, is length times breadth. Then these two here, because we have two of them, the two faces, so I have two. The length here is 16 inches, and the breadth, this is the length, this is the breadth of it. Length here, breadth here, that is 14 inches. 16 times 14, 16 times 14, that is 224 multiplied by 2. 2 times 224, that will be 448, equal to 448. And what is the unit? Unit is inches. So inches squared as the area of front and back. Now let's look at the other side of it. Let me use a different color. Area of this side here, and exactly the same side right here, which is hidden. Let me call it left and right. So area of left and right side will be 2 of them multiplied by the area of each, which is length times breadth. And the length there, the length here, let's call this the length, which is 14 inches. Let's call the 5 inches the breadth. So 2 times 14 times 5, which is 2 times 14 times 5 is 70. 2 times 70, which is 140. What is the unit? Inches. Inches squared. That is the area of left and right side of the cuboid. Then lastly, the other remaining side, let me use a different color here. Let me use color yellow. You have a top here, area of this top, and exactly the same thing at the bottom. So area of top and bottom, area of top and bottom will be 2 multiplied by length times breadth. And that will give us 2 multiplied by, what is the length there? The length is this long side here, which is 16 inches. The breadth is this side, which is 5 inches. So 16 times 5. 16 times 5, which is 2 multiplied by 16 times 5 is 16 multiplied by 5 is 80. 2 times 80 is 160 inches square. So total surface area of the cuboid there will be, where is the first one? 448. This plus this plus this. So 448 plus, the second one is 140, and the last one is 160. All of them is inches square. Okay, adding them up, 448 plus 140, 140 plus 160, that is 748, 748 inches square as the surface area of the cuboid. And the volume, on the other hand, is V, length times breadth times height. The length of the cuboid is 16 inches, the breadth is 5 inches, the height is 14 inches. So let's plug in those numbers. 16 times 14 times 5. Okay, using the calculator to get that, 16 times 14 then times 5, that is 1120 inches cube as the volume of the cuboid. And this brings us to the end of this question on the surface area and volume of a cuboid or a rectangular prism. Another thing we look at is surface area and volume of a cylinder. Now, a cylinder is a shape like what I have here on this diagram. As you can see, it's made up of two circles, the circular top here and the circular base. Then we also have the area or this cross section here, which we call the curved surface. Let me use a different color to highlight that. This side here is called the curved, the curved surface. So how can we get the surface area of a cylinder? We get that by the area of the circular base plus the area of the circular top plus the area of this curved cross section. And we know that area of the circle is pi r square. That is the bottom plus another pi r square, the top. Then this cross section here, this curved surface, the area is 2 pi r h. So if we add all of this together, pi r square plus pi r square is 2 pi r square. Then plus this 2 pi r h there, 2 pi r h. So total surface area, TSA, for a cylinder is 2 pi r square plus 2 pi r h. Now, we can factorize something here. We have 2 pi r here. We have also 2 pi r here. So 2 pi r is common. So I'm going to bring it out. I have 2 pi r bracket. Then I have r square here. So when I bring out 2 pi r, I will be left with 1 r. Then here I will be left with h. So total surface area of a cylinder is 2 pi r multiplied by r plus h. This is the total surface area of a cylinder. The volume, on the other hand, V, or volume of a cylinder, is pi r square h. That is the constant pi Now, the volume of any shape at all is the area of a uniform cross-section multiplied by the height. That is where we got this for cylinder. The uniform cross-section here is, or the uniform shape is the circular base and the circular top. So the area of the circular base, which is pi r squared, multiplied by the height, give you the volume. So volume of a cylinder is pi r squared h. So with that, we can solve some question. We have an example here. So calculate the surface area and volume of the following cylinders. We start seeing with, let me call this A, and I call this B, I call this C. So for A, let's start here. The total surface area, TSA, of a cylinder is 2 pi r bracket r plus h. As we established earlier, it's right here, 2 pi r bracket r plus h. And in this cylinder, the radius is 4 meters. Pi is a constant, so I have 2 times approximately 3.142, the value of pi, times the radius, which is 4, bracket, again radius 4, plus the height, which is 8. And that gives us 2 times 3.142 will be 2 times 3.142 times 4 gives us 25.136 multiplied by 4 plus 8 is 12, multiplied by 12. That is 301.6 approximately meter square as the total surface area of this cylinder. The volume, on the other hand, let me use a different color for volume. Volume is pi r square h, and pi is 3.142. Radius is right there, 4 meters, so 4 square, and the height is 8 meters times 8. That will be 3.142 times 4 square is 16. That is 4 times 4 times 8. 3.142 times 16 times 8. That is 402.2 approximately. And what is the unit? The unit is meter cube. Meter cube. The volume of that cylinder. Okay, let's move on to B. For B, then I use a different color for the total surface area. Total surface area of a cylinder is 2 pi r multiplied by r plus h. And r there is 10 meters. So I'll have 2 times 3.142 times 10 meter bracket r, again 10 meter plus the height. The height is 13 meters, 13. And that gives us, let's plug this into calculator, 2 times 3.142 times 10 is 62.84 multiplied by 10 plus 13 is 23, multiplied by 23. That is 144. 1445 rather 0.32 or 3 approximately meter square as the total surface area. The volume V is pi r square h. Pi is 3.142. The radius is 10, so 10 square, and the height is 13 times 13. That is 3.142 times 100, that is 10 times 10 times 13. That will give us 3.142 times 100 times 13. That is 4,084.6. What is the unit? Meter cube. That is that for question B. Now for question C, let's do it right here. Again, using a different color. Let me increase the thickness of this color to 3. It's not okay, very good. Question C, I have total surface area is equal to 2 pi r bracket r plus h. Excuse me. And that will give us 2 times 3.142 times the radius, which is 5 bracket 5 plus the height, which is 12. That will give us 2. Okay, let me just put this number into the calculator right away. 2 times 3.142 times 5, 31.42 times 5 plus 12 is 17. And that gives us 534.14. What is the unit? Centimeter square. And the volume is pi r square h. The pi is a constant 3.142. The radius, what is the radius? 5 square, and the height is 12. Am I right? Yes, 12. So that will give us 3.142 multiplied by 5 squared is 5 times 5, which is 25, and multiplied by 12. 3.142 times 25 times 12 give us 942.6 centimeter cube. And that brings us to the end of this very question, and also the end of this lesson. I'm sure you found it very useful. If you do, don't forget to subscribe to the channel so you get more of this. I'm going to solve a lot of questions from past question IGCSE. So hit the subscribe button and also turn up the notification so that you get notified whenever I release new content. Thank you.